Hello everyone, once again welcome to the Genius Science Academy. Today we are going to discuss about the periodic classification of a element, that is the related for the 10th class science. Let's see what are the components come in these chapters. Okay, let's begin it. Okay, first of all, remember that we are going to see the classification of an element. It means that the arrangement, the arranging the elements into the different groups. The arranging the element into the different groups on the basis of the similarities in their properties is called the classification of a element. Look here, today we see that the lot of the elements we found in our the nature, these all our elements have to be classified into the different groups, different periods, according to their the properties, according to their similarities. That is known as the classification of elements here. If we see just a small example, if we are going to see here, if you take a small container, put all the different type of grains in them, for example rice, right, put the wheat, put the jawar, put the ragi in that. If we want to separate these grains or these food items, we see the properties, we see the appearance, we see the sizes, categories. According to these points, according to on these idea, we are going to separate all these points here. Okay, it means we are going to separate the rice, we are going to separate the ragis, we are going to separate the wheat, we are going to separate the jawar, we are going to separate the rice. We take the rice one side, right? We take all the ragi one side, right? We take all the ragis one side. Why? Because they are having the same properties or the same characteristics. Ragi having its own characteristics, rice having its own characteristics, jawar having its own character. How we are going to bifurcate the substances in our day-to-day life, same we have to separate the elements also, but there is a little bit difference, the separation of the element and the separation of the normal substances. It means that's why we are going to see that the arrangement of a element into the different groups, right? Into different groups on the basis of the similarity in their properties. According to their properties, we are going to classify the elements here. Okay. Next point, the classification of a similar element into the groups make the study of elements easier. Why should we make the classification of an element? Why should we have to put all the elements into the different categories? Why should we keep these elements into the different rows and the columns? Why? Because when we are going to separate them, when we are going to classify them, it will help us to study about the nature and the properties of an element very easily. Okay. Next point is that total there are the 118 different type of elements we known so far, not 114, there is more than 114. I mean near about 118 elements we know up to these days. This classification of elements did by the many persons, many scientists in the earlier days, or we can say the lot of the different scientists are attempted to classify the elements. Let us see how many classification are did by the earlier persons or the earlier scientists here. First of all, if we see the earliest attempt of classifying the element or the classify the element was grouping the known elements, about 30 elements, into how many groups? 2 groups called metals and non-metals. It means earlier we know there are the metal elements present. One is the metal, right? Another one is the non-metal, non-metals, metals, right? These are the 30 elements are known at that time, and they are classified into the how many groups? They are classified into the 2 groups. 2 groups. One is the metal group, another one is the non-metal group. Right? Further, what happened? This classification goes wrong because of, means the classification of this elements goes wrong. Why? Because of some element shows the property of metalloid. It means these elements having the properties of both as well as metals and non-metals. Remember that. They are known as the metalloids. Metalloids having the properties of both the metals and the non-metals. Here we can see them. Okay, these the properties of non-metals and metals, which are discovered later at that days. This was the first attempt did by the scientist. There are the only 30 elements are known at that time, and they are divided into the 2 groups. That is, one is the metals and the another one is the non-metals. Okay, let us see the next. The Vernier Triads, or the classification we can say here. Okay, well, let us see what are the points are there here. Okay, the Vernier classification classified the element in increasing order of their atomic mass into the group of 3 element triads. Look here, he tried to classify the elements in the increasing order of their atomic mass. According to their atomic mass, Vernier tried to classify the elements here. In how many groups he classified the 3 elements called the triads here. In each triad, this is the important point, listen here. In each triad, the atomic mass of the middle element, remember that atomic mass of the middle element was approximately equal to the average atomic mass of the other 2 elements. Here, look here, if there are the 3 elements here, the atomic mass of the middle element is approximately equal to the mass of average mass of these 2 elements. Are you getting my point? Like this, he is classified the elements here. The defect in this classification was, what is the defect? Why it is failed here? Let us see. Was that all the known elements could not be correctly arranged into the triads. It means at that time the elements are known, are not classified in the form of increase of their atomic masses. That's why the Vernier Triads is failed in the classification of elements. Let us see the next point, that is the Newlands octave. Newland octave. He is also the scientist who tried to classify the elements here. Let us see what he did here. Newland classified the element in the increasing order of their atomic mass into the group of 8 elements called the octaves. He also tried to the classification according to the increasing order of the atomic mass into the group of 8 elements called octaves. In the 8 category he was classified the element. Like the musical notes, you can say that, like a musical notes. What happened further? He found that when the elements were arranged in the increasing order of their atomic mass into the octave, there was similar properties in 8th element. It means when he was going to classify the elements according to their atomic mass, he found the 8th element is similar to the first element or the other elements. And what are the defects, what are the problems in the Newlands octave? Let us see that. First point here, in the known element and element discovered later could not be correctly arranged into the octave. It means the known elements at that time the known elements and the elements which are discovered laterly or little bit laterly, they are not classified into the octaves method. Why? Some of the elements having the different properties, some elements having the different properties were placed in the same row. Look here, the cobalt, nickel having the different properties. What is that? Cobalt and nickel having the different properties, but they are kept in the row of fluorine, and they are kept in the row of chlorine, and they are kept in the row of bromine. Look here, even though the properties of cobalt and nickel are different, they are placed in the row of the fluorine, chlorine and the bromine. And even look here, iron is also having the same property as the cobalt have, right? Cobalt has. These iron and the cobalt having the same property, even though they are kept in the different rows or in the different columns. So the Newland octave is also failed to classify the elements. You can see here the point, we can see here. Look here, the cobalt and the nickels having the different properties, they kept along with the fluorine, chlorine and the bromine. Even the iron having the properties of a cobalt, similar properties of the cobalt, nickel, and they placed in the different row. So the Newlands octave is also failed to classify the elements. Next point is that Mandl's, right? Let us see the Mandl's. Mandl's classification. Mandl's classification. First of all, the Mandl's given the statement, that is, he quoted some points. What is that? The properties of a element are periodic functions of their atomic mass. Look here, he said that the properties of a elements are periodic function. It means the properties of a element, if you take the hydrogen of the property, helium of the property, carbon of the property, that are periodically functions to their atomic mass. Atomic mass. He stated this statement. After that, after the classification, when the Mandl start to classification, he also followed some methods. Let us see how he was classified all the elements according to him. Look here, the Mandl's periodic table, we can say that. Right? Mandl classified the element in the increasing order of their atomic mass and similar in their properties. He chosen the two important points to classify the elements. First, he chose that the atomic mass in the increasing order. And second thing is that he selected the similar properties of their element. It means element having the similar properties. According to the Mandl, he selected the similar properties elements and the increasing the atomic mass after he started the classification of the elements. And let us see what he did. The formula or the formula of the oxides and hydrides formed by the element was also basis of the classification of a element. It means the oxides of the element. You heard in the previous chapter what are the oxides. Oxides of elements he took here, and hydrides also he took to classify the elements here. Next, here look here. Mandl's periodic table has, remember, 6 horizontal rows. How many? 6 horizontal rows and 18 vertical rows. That is the 18 vertical rows. Vertical, like this. Remember here, 6 horizontal. 6 horizontal rows, and these are the vertical columns. Remember that, rows, and these are the columns, right? Mandl is having 6 horizontal rows and the 18 columns. Look here, next, first 1 to 7 has 2 subgroups called A subgroup and B subgroup. It means from 1 to 7 having subgroups. Subgroup A and B, right? Next, the group 8 has 3 rows of elements. We having the similar properties were placed in the same group. In the 8th group, he placed the element which having the similar properties. There are the some space left vacant in the table to accommodate that element to be discovered in the future. It means he left some what do we call that? He left some space here. Why? Because he predicted that in the future some are going to discover the different element. The discovered element may be placed according to his plane here, according to the properties, according to the increasing of atomic mass here. Let us see the merits of the Mendeleev's periodic table. Mendeleev's periodic table. What are the merits? Let us see. Here the first merit is the element were classified. Element were classified on a more fundamental basis of their atomic mass and properties. First of all, this is the merit of the Mendeleev's. That is, he took a very basic concept to classify the elements, that is the atomic mass and the properties. Second one, the space were left vacant to accommodate that the element to be discovered in the future. It means the vacant which he is left in his periodic table. Why? Because he predicted that some elements will be discovered in the future, and all the discovered elements can be placed in the vacant left by him. He could predict that the properties of an element which help in the discovery of a new element, and he also predicted, just I told you that the predicted the properties of an element which help in the discovery of a new elements. Next one, the inert gas elements or the noble gas element discovered later could be placed in separate groups without disturbing the table. Right? Inert gases we are going to see. Noble gases. Noble gases. Noble gases. What are the? Argons, neons. These are the noble gases. Right? They are kept separately in the group without disturbing the Mendeleev's periodic table. And there is a little bit defect also we are going to see in the Mendeleev's. What are the defects? Let us see here. Some elements are not arranged in the increasing order of their atomic mass. Some elements are not classified here, like which one? CO, Ni, Te is placed before I, etc. These are all the elements. These all are the elements are not arranged in the periodic table according to their increasing, according to their atomic mass here. Second, the defect or the second problem in the Mendeleev, the hydrogen is not clear because it shows the properties similar to the metals as well as non-metals. Means the hydrogen is the not clearly having the space in the Mendeleev's periodic table. Why? Because it shows the properties of metals as well as non-metals. And the position of the isotopes of elements is not clear. Isotopes, right? Isotopes formed by the combination of two different elements are known as the isotopes. They don't have the clear place in, or the position in the Mendeleev's periodic table. These are the defects we see in the Mendeleev's periodic table. Let us move the furtherly. This is the periodic table, right? What you see in the picture, that is the periodic table, modern periodic table we can say. Look here, If you observe this periodic table, you come to know the how elements are classified into the different groups and the types here. We can say that the Mendeleev's modern periodic table also we can say here, right? Let us see. According to the color here, these color represent the alkali metals. Here, nickel, Na, potassium, Rb, Cs, Fr, and these are the alkaline earth metals. This is the transition metals, other non-metals, halogen elements, noble gases. Here we can see the noble gases or the inert gases. Helium, neon, argon, krypton, xenon, rheon. These all are the idle gases or the inert gases we can say. And this is the rare earth element. What are those? 21, 39, 57, 71. Here we can see in the periodic table according to that number here. Which one? 21. And here let us see where is the 39, 39, 57 and 71. Here it is. Where it is? 81, 81, 81, 71. These all are the, let us see, these all are having the very rare element present in the earth, right? This is the periodic table, and I told you that there are the 18 groups. You can see here. These are the 18 groups. You can see the number 1, 2, 3 up to 18 here at the end point. These are the 18 columns, and they particularly 1, 2, 3, 4, 5, 6, 7, 7 rows, and these are the separate, right, series and the acetonide series. These are the two separate rows we are going to see here. Okay, this is the Mendeleev's periodic table, which is furtherly took by the many scientists and classified the element. Let us see the what is the having the properties of the modern periodic table here. Look here, modern periodic table. In the modern periodic table, the elements are arranged. Look here, same concept also took here in the modern periodic table. That is the arrangement in the increasing order of their atomic mass. They also took the same topic, same point to classify the element in the forming of the tables having the 7 horizontal rows. Here in the modern periodic table, they having the 7 horizontal rows and 18 vertical rows, or we can say the vertical columns are called groups. Just I shown you in this. I shown you in previous slide that the having the 7 rows and 18 columns. 7 rows and 18 columns. See here carefully. There are 7 periods of elements as follows. First two elements H and He, that is hydrogen and helium, very short period. And second period has 8 elements. Second having the 8 elements, that is Ni, Ne called short period. And the third period having the 8 elements, that is the Na2 Ar called the short periods. And the fourth period also has 18 elements from K to Kr called the long period. And the fifth period having the 18 elements from Rb to Xc called the long period. and next the sixth period having 32 elements from CS to Rn called the long period, and the seventh having the 28 elements Fr to atomic number 114, it means 114, that is incomplete period. In the 14 elements, each sixth and seventh periods are placed separately at the bottom of the table. Below just we saw na, that means the element 14 elements of the sixth period from LA to LU are called the lanthanides. Last two columns, just I told you different columns, and the 14th element is called the AC to LR. Up to these are the periods of the modern periodic table. Just I explained you before in the slide. Means it having the modern periodic table having the 7 horizontal. How many? Remember that. How many? 7 horizontal rows and 18 vertical columns, right, in the modern periodic table. Let us see. Look here, this is a very important, the grouping of elements. There are 18 groups as we saw in the before slide. They divided into 9 main groups. How many main groups? 9 main groups. They are 1 to 8, 1 to 8, and another one is 0 group. These are the 8, this one 0, one is a 9. The group 1 to 7 has 2 subgroups. How many groups? A subgroup and B subgroup. Which one? 1 to 7. And group 8 has 3 rows. How many rows? 3 rows of elements, and O group has only 1 row of elements. Look here, what are the A subgroups? What are the B subgroups? Let us see here. The A subgroups are called the normal element. Remember that. A subgroups called the normal elements. Second, B subgroups are called the transitions elements, and lanthanides and the actinides are called the inner transition elements. Last two rows kept in the periodic table, that are the lanthanide and the acetinide, are called the inner transition elements. Look here, group 1A element are called alkali metals. Just I shown you in the before, you have to clearly observe that. If you get confused, please rewind this video, you will get the clear image or the picture about the periodic table. And second group, element having the alkaline earth metal. 17th 7A elements are called the halogens. 18O group called the noble gases. I explain you argon, neon, krypton, that gases. And in the group of element having the same under the number of valencies, electrons. Group 1 element have 1 valency electron. First group having, it means hydrogen. Hydrogen having only 1 valencies. Group 2 elements having 2 valencies. Group 3 having 3 valencies of a electron, etc. Let's see here. It means first, right? First group having 1 valency. Second group having 2 valencies. Third group having 3 valencies, like etc. In this periodic table, all the elements contain the same number of shells in the modern periodic table. Okay, let us see further. Properties of elements in the periods and groups. What are the properties here? What are the properties are kept in the mind to classify the elements according to the valencies, according to the atomic size, according to the metallic properties. Let us see one by one here. First one, valency electron. In the in a period, the number of valencies electron increases from 1 to 8 from left to right, and the number of shells in the same. It means the from 1 to 8, or we can say the left to right, there is increase in the valency of electrons, right? Look here, from left to right in the periodic table, from left to right. It means the increase in the valencies, increase in the electron valencies from 1 to 8. Second one, valency. In the period of the valency of an electron increase from 1 to 4 and then decrease, right, from 1 to 4th group or group, valency increases, and from 4 to 0, it means left to right, it decreases. And third point, atomic size or the radius of the atom. Look here, remember that this is the atom here, this is the nucleus, this is the nucleus, this is the nucleus. The distance between from nucleus to the circumference of an element is known as the radius. Right? In the periodic, the atomic size of the element decrease. Remember, the atomic size of the element decrease from left to right, because the nuclear charges in number of protons increases. In the nucleus, the number of protons are increases from the left to right here in the periodic table, and so the electrons are called the closer to the nucleus. It means if the protons are increases in the nucleus, the electron which are present in the orbit, they are very closer to the nucleus or in the center, we can say that. Next one, the metallic period or the electropositive nature. In a periodic table, the metallic properties of an element decrease from the left to right. It decrease from left to right here. If you take this is the left, left to right in the periodic table. According to when you face the periodic table, your left to your right. Right, the metallic properties goes on decreasing from left to right. And the last point of this unit, we say that the non-metallic properties of electronegative nature. I mean, this is also the properties kept in the mind to classify the element or in the periodic table. What are this? The non-metallic properties of an element increases from the left to the right. Non-metallic properties, metallic properties, these all are the points kept in the mind into classification of a element. One is the non-metallic, and another one is the metallic, another one is the atomic mass, right? Valence is, right? Another one, and what are the non-metallic happen, metallic is also happen, and the atomic mass is also, and valence is also happen, and the what we call the another one point, etc. Let us say that, etc. These all are the points they kept in the mind to classify the elements in the periodic table, or they substitute the element in the periodic table by keeping these points in their mind. So, dear student, up to this we are discussed the classification of elements from the different persons in the different time according to their ideas. So, thank you very much to listening my class. Please subscribe, like, share, comment, and I heartily request you all that please subscribe the channel to get the more knowledge about the science classes. It will help you in the competitive exam, and ask your friend come and join with our family. Thank you very much.